Our next speaker is Brooke Pallas. Did I pronounce that right? Pallas?
Yes, yep.
Okay, of the University of Michigan. He joined the Unit for Laboratory Animal Medicine as a faculty veterinarian in July 2020 after completing his postdoctoral fellowship in laboratory animal medicine with ULAM and the University of Michigan. Prior to his time at he completed his undergraduate training in genomics and molecular genetics and his veterinary degree at Michigan State University. Dr. Pallas's research interests are directed toward the design, production, and improvement of clinical management and phenotypic analysis of genetically modified small and large animal models. He will be presenting on the use of compressed paper versus corncob bedding and how to balance the physiological, health, and behavioral aspects of mouse welfare. Thank you.
Excellent. Thank you, Pat. I appreciate that intro. And good morning, everyone. Thank you for joining this morning. And I'd like to extend my thanks also to the organizers of this conference. I think it's a great opportunity to really learn about a whole spectrum of various things that we don't always think about every day. And so today I'll have the opportunity to share with you some of the work that I've done on the refinement aspect of 3 Rs, specifically for mice and in relation to the bedding that we provide in their caging environment. Not always the most thrilling of topics, but I think some of the data that I get to share with you today will be a little eye-opening, a little interesting. So again, my name is Brooke Pallas. I'm a clinical veterinarian at the University of Michigan. And this is work that has kind of been a work in progress for the last couple of years. Okay, so if you guys have, just off the top, any continued interest or want to dive in deeper to the details that we're going to talk about today, everything that we're going to present today has been published already, and it is available through these 2 different publications for those of you that are interested in some of the more detailed aspects of it. So our topic today is bedding and specifically for mouse cages. And so when we think about bedding and we think about the potential for changing to a new bedding, first thing, what do our regulatory documents suggest or tell us that we should be considering thinking about bedding? And so, starting with the guide, what does the guide say? We need to provide something that provides really to kind of species-specific behaviors, right? So we're looking for, can the bedding provide a source of foraging, burrowing, or digging? Can they use it for nest building? Can they use it to increase their own body temperature, which we rely on the nesting aspect a lot in our laboratory mice? But there's a lot of other aspects to consider too, and we'll touch on some more even later, but we have to think about the absorption of that bedding. Is it absorbing the urine or feces? Is it helping to keep our animals clean and dry? We know that that's highly important. And then not only sort of the direct impact on the physical aspect of the animals, but also what about the microenvironmental parameters of inside that cage environment? So what is it? How does the bedding have an influence on gaseous aspects such as ammonia within the cage? And then there's sort of the reality of how often does the cage need to be cleaned based on how the bedding is performing in there? And so, our sort of standard unanimously is that cages need to be fully sanitized at least every 2 weeks, which is how most cages are processed. So by far and away, at least in the United States, the sort of standard mouse bedding is corncob bedding. And so this is a product that is obviously an agricultural-based surplus product. It's produced in mass, and the dried corncob products are then sort of processed into these 1/4 or 1/8 inch crumbles, where this is then the bedding that's dispensed into the cages that the mice will live on. These this bedding is highly promoted by its manufacturers. It's a very cheap material, obviously. It's produced in extreme surplus. And there are some solid attributes about it. It is relatively absorbent, and it can have some impact on the ammonia levels within the cage, but as we will show later, they're quite limited. But corncob kind of comes with a lot of other potential aspects that maybe we're not always thinking about too, that are quite negative, or at least research confounding aspects. We know that there are documented studies where corncob is readily ingested by research mice. And so this can obviously play a huge role on any sort of dietary studies where measuring the direct intake volume of each individual mice would be disrupted, and not to mention what sort of microbiome implications ingestion of corncob could have. Corncob is an agricultural product, so there's a huge seasonal variability. There is also a massive regional variability depending on where that source material is coming from. And then there's the whole biosecurity risk. Obviously, this product is exposed to many potential avenues of wild rodents and other animals. These are all going to have various levels of unknown disease or parasite status. And so if we really want corn cob to be clean for our research animals to remove variability, it requires pretty extensive processing, such as being irradiated or autoclaved to really make that a decontaminated product. Now, obviously, corn cob is not the only bedding available by any means for research animals. But it's important to, again, consider the bedding that we are providing. So there are things like cedar shavings. We can use aspen chips. There's the Carefresh paper bedding. There's sort of various modifications to paper bedding. Yesterday's News is a brand of rolled paper. But we also know that many of these come with their own sort of other aspects of research confounding possibilities. And so if we think back to the guide kind of dives into this a little bit more extensively than we've covered, and it recommends that there's a whole host of other aspects that we should be considering. And so bedding products should be critically evaluated based on things such as biodegradability of the bedding. Is the bedding potentially inducing a toxicity in some way? Is there dust production associated with that bedding type? Is it palatable? Is it comfortable? Where's the cost at on these? How largely available is this product? Does it have seasonal variability? And then again, some of our more tangible logistical issues, like what does it do in our cage washer or bedding dispensing machines? And then always, again, considering its effect on research results. And so we know that things like the softwood beddings are giving off these aromatic hydrocarbons, and that they can activate hepatic microsomal enzymes, leading to research confounding events, especially in our longer term studies with aged animals. Aspen bedding, we know that it can emit particulates, and it can cause respiratory pathology from that perspective. And then the other sort of commercially available things might not be compatible with massive amounts of mouse caging that we need to take care of, and having them compatible with the standard equipment available for that, like bedding dispensers. So many things to consider sort of just off the bat when we're thinking about making a bedding change, or really trying to refine the bedding that we do provide. So this kind of led us to our institution in specific was looking for, is there another option? Is there something we're comfortable with that really represents an improvement to our process and not just a change for change's sake, right? And so this is by no means an endorsement of the Anderson's company, but we do utilize many of their products here, and this was a different line of bedding that we wanted to sort of further investigate. So they provide this, they term it Puricell bedding. It's essentially a compressed paper bedding. So Puricell is at its core, it's a mixture of water and cellulose pulp that comes exclusively from 100% virgin paper sources. And it's delivered obviously in bags. It can come pre-irradiated, but the manufacturing process basically makes it nearly sterile to begin with. And it comes in these compressed little paper squares that you see here. And so, you know, when we think about refining our something in our animal environment, I think it's kind of exciting and kind of important to think broadly. And as technologies across many different industries change, you know, as researchers, how can we grab onto those changes in other industries and help them to improve our setting? And so we tried to design a few studies to really evaluate this bedding. At a retail level, it is marketed with many seemingly high value differences, such as a very high absorbency rate, very dust free. It has a bright white appearance that can help you do health checks easier. You know, lots of things that necessarily weren't validated, but seem logical. And so going to kind of walk you through how we evaluated this at our institution and how how the work that we did helped us either gain confidence in it for certain aspects and not so much for others. So just at the start, you know, we looked at, okay, what are the categories of things that we need to consider based on what our regulatory documents are recommending that we do, such as biodegradability, the dust level, how available is it, and then, you know, kind of the unknown, more gray area aspects of, you know, can we pin down its reduction of research interference? What can we learn about how this bedding can mitigate ammonia levels within the cage? And can we really show with data that species-specific behaviors are improved or at least more readily facilitated with this bedding change? So I'd like to kind of walk you through our process here. First thing that we really zoomed in on is the effect of bedding type on cage change interval for individually ventilated caging. So from a logistical standpoint, the first thing we really wanted to know is what is our current rate of spot changing? And so what a spot change is in our definition is that if a husbandry technician can visibly tell that greater than 25%, so a quarter of the cage is visibly wet on a daily health check, then that cage requires what we call an off-cycle change. So every cage is going to get changed every 14 days, but on a daily health check, if greater than 1/4 of it is visibly wet, we will just pull that cage out and do a spot change. So we wanted to sort of first understand, you know, what is on a campus where it's 100% corncob bedding for all of our mice, what is our spot change rate? So we looked at this data and collected it with many different husbandry technicians. So we looked at 3 different facilities across 14 different mouse rooms, which were all on ventilated caging. And this data represented over 2,300 mouse cages of data. And so what we did is for this initial group, we had them, the husbandry technicians, record every time they had to do a spot change for two full week cycles. So 1 month before, and then this was during our phased changeover to the compressed paper bedding. And then we continued it for 1 month after. So the data is 1 month before and 1 month after the transition of a bedding change. And so how did this data come out? So if we're looking at the spot change frequency for individually ventilated cages across multiple facilities, where each dot on this graph is representing a different mouse room, the data really came back pretty consistently. Somewhere between 20 to 25% of the cages during the time period that we looked at were being spot changed, and that held consistent across a rather large proportion of technicians, facilities, and rooms on our campus, which gave us pretty significant confidence that this was a real value we were looking at. And so the kind of first question was, did we look at too short of an interval? You know, was this too zoomed in, and maybe it was just a snapshot, it wasn't representative? So on a subset of these rooms, we actually continued this work for an additional month. So over the course of 2 months, our data really did stay steady, somewhere again in that 20 to 22, 25% range on average was our spot change frequency, specifically in individually ventilated caging that was on mice housed on corncob bedding. So this is when the data kind of got interesting. So once these facilities transitioned their rooms over to Puricell bedding, or this compressed paper bedding, we continued to track the spot change rate for those specific rooms over time. And so what we ended up finding is that unanimously, every room underwent some level of a decrease in the absolute number of spot changes that were required within the mouse cages once transitioned to the new bedding type. And so this was very encouraging. It was, you know, it obviously showed a significant difference. And the first thing that we really had to make sure was that we were still applying the same criteria for defining what a spot change is. And so, you know, the 25% visibly wet is what triggered a spot change. And this was held consistent across all of our technicians that were assisting us in this data collection. One of the other ways we tried to look at this data was at a institution like ours. We have many mouse rooms of various sizes, and so we were considering, you know, is there a difference when the size of the room increases on the spot change frequency? And so if we look at as the room census increases for rooms that were housed on corncob, as the room gets bigger, there's more spot changing. I think that's pretty logical to assume. And then we could calculate sort of a rate of spot change in relation to room census. Now, what was really interesting is that when we calculated this same rate for once the rooms were transitioned to a compressed paper bedding, the rate of increase is significantly decreased compared to when the cages were on corncob. And so, you know, not only are we doing less changing overall, as the rooms get bigger, we're actually continuing to see that decrease, which was encouraging. So trying to think about this change in rate and this change in absolute spot changing in a little bit more of a tangible way is to relate it back to, okay, how many less spot changes are we actually doing? And so these are numbers where at the time, at the size of our entire institution, we kind of extrapolated out. What if we changed over 100% of the campus to this compressed paper bedding? If everything's on corncob, we were doing somewhere close to 11,000 spot changings every 2 weeks. And if we went to a compressed paper bedding, based on our data of the facilities that we examined, you know, we would really bring that down at somewhere around 7,600 less spot changes every 2 weeks. Now, you know, spot changing, I think, directly relates to our time and labor from a logistical perspective, but we also are trying to think of our material reduction and a refinement to our overall facility process as well. And so if we think about how many bags of corncob does that mean that we're using exclusively for spot changing over those 2 weeks, and how many bags of compressed paper bedding would we be using? We're looking at almost 70 less bags of bedding every 2 weeks required just for spot changing our cages. And so, you know, what excited me about doing this work is that not only was there logistical and tangible applications to the efficiency of our facilities, but as we'll touch on next, it also relates to improvement in the welfare of the animals, which I think, any high quality refinement it touches on multiple aspects of how facilities function. It's about the animals first and foremost, but if there are other additional benefits, that's how we can sort of really weigh our refinements. And so that's what I'd like to focus on and share with you now is how does the bedding type actually affect the microenvironmental parameters that the mice are experiencing within the cage. And so to kind of walk you through this, just in general, we zoomed in on one facility. We do not have at the University of Michigan very many static cages, so we kind of chose our one facility that does have some static caging, but also individually ventilated caging. And so we utilized a gas detector meter that was specifically for ammonia, and we utilized over 100 IVCs that were housed on both corncob and Puricell. And as we'll walk through, we tried to standardize our data in many ways. And so one of the things that we ran into early on is when you think about comparing ammonia levels across different cages, pretty obviously those cages have to be at the same amount of dirty, right? You can't compare a cage that's been sitting on the rack for 13 days compared to a cage that's been sitting there for 10 days. And so we had to standardize across how many days post last change, which we'll touch on, and then also what's in those cages. Not a cage full of adult males is probably going to have a different ammonia level than a cage with young, freshly weaned females. So we'll kind of walk through that. But in this part of the study, we also extended it to static caging, so just not ventilated caging. This is on a much lower scale. We do not have very much of it, like I said, but these cages are cleaned every 7 days and changed out here every 7 days. So we standardized it for how many days dirty it was, as well as what group of types of animals were in those cages. So to kind of run you through this data, in general, the compressed paper or the Puricell cages have a decreased ammonia level in general across the board when we're looking at absolute numbers of parts per million for ammonia. So this is in individually ventilated caging. So somewhere around the 20-ish area for the average ammonia level in a corncob IVC versus Puricell is down very low, somewhere in the 2 to 5 parts per million. So it gets a little, these numbers are a little arbitrary, I would say, from the sake of we don't have a hard cutoff for what the ammonia level should be in a mouse cage. There have been some studies that have looked at nasal pathology, oropharyngeal pathology, and trying to relate it to ammonia levels, but far and away, we still kind of go off the NIOSH, the National Institute for Occupational Health and Safety levels, where they really set the ammonia exposure limits for humans at about 25 parts per million, and that's averaged over an 8-hour workday. So just for kind of setting your brain straight on this, somewhere around the 25 parts per million is what we're looking to stay under. Now, obviously, the machine can max out at 100, and some cages are up there, but on average, we're sitting very low in the IVCs. Now, when we shift to static caging, what do we see? And so this is, again, absolute numbers of ammonia in parts per million on 2 different bedding types across static caging. And basically, we saw our data disappear. Our differences completely, we just did not observe them in static caging. And so one of the thoughts that we had is there a volume effect? And so basically, can we get the ammonia levels to shift if we just put more bedding in? Is there some aspect to that? So we had because we utilize mechanical bedding dispensers for corn cob, we have a very standardized level of corn cob that's put into each cage. And this really wasn't in place for the beginning of our transition to compressed paper. And so part of it was, how much really should we be putting into each cage? And so we trialed an equivalent amount of corn cob in the compressed paper, and then we kind of did a 1.5x trial and a 2x trial of bedding volume. And it didn't have an effect, basically. Our ammonia levels were very consistent with corn cob, but remember, this is specific to static caging. So I talked about how we tried to standardize our results across the amount of dirty that each cage is, so days post last change. So we categorized the cages that were available to us in 10, 11, 12, and 13 days since their last change, and then day 14 they'd be completely changed out. And what we saw is that across all the days, compressed paper bedding has a significantly decreased ammonia level in ventilated caging. So this is back to the IVCs. Corn cob is having a consistently higher level of ammonia. Now, when we look at that same level of dissection of the data, but in static caging, we see the same thing as we saw with the general ammonia level. Our data doesn't hold true in static caging. Basically, there was really no difference between the ammonia levels in static caging between corn cob and compressed paper. These are, again, because statics changed every 7 days, these were 3, 4, 5, and 6 days sort of dirty. This was our attempt to dissect the data and ensuring that we were comparing cages with the equivalent types of animals within them. So we reasoned that from an ammonia standpoint, we are most concerned with cages that either have the most amount of animals in them or animals that are going to be producing potentially the most amount of urine. So we categorized one group as males over 4 months of age, considering them to be adults and probably having a higher level of urination, or breeding cages that contain pups where, until they're weaned, obviously have a higher density of animals within them. And then everything else being female-only cages or young males were kind of in this other category. And so in the IVC cages, when we standardize for how many days post-change, we see a continuation of what we saw in all of our earlier data. The compressed paper is really holding the ammonia levels significantly lower than the corn cob across all of the types of groups of animals within the cages as well. And when we looked at types of animals within the cages in static caging, again, same trend. The data does not hold. Really trying to basically show us that it's probably the individually ventilated caging itself that's driving the difference, and that static caging, we're just not seeing those results. So that kind of really made us think, like, what is it about it? Is it just the caging, and it could be? Or is it some sort of intrinsic aspect of the bedding that could be driving the data that we're seeing? And so one thing that became abundantly clear when you work with this bedding is that it's very absorbent. These little compressed squares, if many of you have worked with them, they expand very quickly the instant that they get wet. And so we said, let's see if we can set up a little mini experiment to sort of quantify this. And so basically what we did is we basically took the bedding, we put it into 50 mil conical tubes, and we added 20 mils of water to it. We shook the tube, and then we let it sit. And basically then we would strain it out and measure how much water was absorbed at 2 different time points. And so we did a 2-minute time point and a 60-minute time point. And basically what we see is that we call it absorption capacity. Basically 100% or all of the 20 mils of water was completely absorbed in the compressed paper bedding after 2 minutes, whereas only a few of the mils was absorbed in the corn cob bedding. And then when we let the bedding sit in the water for an hour, over time the corn cob does absorb an additional amount of the water, but still only up somewhere in the 6 to 7, 8 mil area, whereas the Puracell or the compressed bedding held on to that water that it had absorbed. So its absorption capacity is significantly higher than corn cob, even though manufacturers will promote and market the absorption capacity of corn cob. Then the other way to think about it is not just absolute absorption, but what about like superficial absorption? Where is that absorption happening? And in the setting of an actual mouse cage, where is it happening? So we kind of inverted our study here, and we basically we filled a tube to a standardized amount of bedding, and then we dripped 10 mils. We dyed the water blue so we could try to visualize it a little easier, but we dripped it down from the top. And the whole goal of this was to sort of simulate how moisture or urine is impacting the bedding within an actual mouse cage. The mice are obviously going to be on top of the bedding. They're going to urinate, and then it's going to go either into the bedding or down onto the cage floor underneath the bedding. And so what we did is we gave it a 5-minute saturation time, and then we compared the results. And we did this several times to kind of ensure its consistency. And what you see is that the water will rapidly run through the crumbles of corn cob, and it will all settle on the bottom, which would be analogous to setting on the bottom of the mouse cage under the bedding. Whereas in the compressed paper, as soon as those squares are touched by the water or the urine, it's absorbed. And basically the bedding at the bottom stays completely dry, and all of the moisture is held in the more superficial level of bedding. And so we tried to kind of put this together in sort of a mechanistic explanation of what we were seeing, and maybe why the data in the individually ventilated caging is so different than in the static caging, given the same parameters in every other variable. And we kind of came to this explanation of, this is a diagram to try to show what we're talking about here, where you'd have mice on top of these blue bedding representations, and when they urinate, it's going to run through the bedding like we know. It's going to sit on the cage floor. But in the individually ventilated cage environment, we know we have this constant rushing of air over the surface of the bedding, but it's insulated from that given the superficial layer of bedding that's not getting touched. Whereas in a Puracell or compressed paper environment, all of that urine is going to be absorbed at the very superficial layer of the bedding. It's going to be in contact with that rushing air in the ventilated caging. And our thought is that it's basically all getting exhausted. Well, why is this causing the change in ammonia that we see? Well, if we think about the biochemistry of how ammonia is happening in the mouse cage, we know that mice are actually excreting urea in their urine, right? And then that urea is acting essentially as a food source for the fecal bacteria within the cage. And it's through that bacterial metabolism that is turning the urea into the ammonia that we're measuring with our meter within the cage. And so our sort of working hypothesis is that the reason that we see such a benefit in ventilated caging and not in static is because the instantaneous absorption of this compressed paper bedding is holding that urea at a superficial level, and the air is allowing a drying effect as the air is exhausted out of the IVC. And so we're also pretty convinced that this is the mechanism, just because urea has a very high nitrogen content, which is highly volatile, and so the drying effect is likely what we're driving, what we're seeing. So that was sort of the ammonia aspect. There's just a couple other aspects that we did look at that I'd like to share with you. So we talked about these species-specific behaviors and how the bedding type can help mice express these. In working with as many mouse cages as we did for these studies, it became abundantly clear that mice can utilize this in bedding very differently than they can corn cob. And it's kind of inherent to the shape of the bedding. The corn cob crumbles are largely spherical. So when they stack up on each other, they just kind of fall back apart. And so if mice push them into a corner or they build them up, they often just fall back down to some level, or they get trampled back down to some level. Whereas the shape of the compressed bedding allows for a much more durable stacking of the material. And as you can see in this picture, they can significantly increase the walls of their nest or the base of their nest, and in some cases even construct a ceiling to their nest. And so we tried to come up with sort of a objective quantitative way of looking at how are mice able to increase the incorporation of bedding into their nesting. And so we created a standardized nesting scoring system where basically it was measuring, is the bedding involved in the foundation or the base of the nest? Is it involved in the walls of the nest? And then is sort of a little bit or a lot? And then also, is there a level of sort of ceiling or a roof to the nest that can be accomplished with the bedding? So we took lots and lots of pictures of mouse nests. We disseminated these across several blinded reviewers to help us to score these images. And basically what we ended up seeing, where a nest score of 1 is kind of it just the bedding is incorporated into the base. When we looked at the corncob caging, we saw lots of 1s. We saw a lot of cages where the nest is involved, or the bedding is involved in the nest walls, and very few to an extensive level. Whereas in the compressed paper, we kind of almost saw the opposite. Across the board, the walls of the nest were constructed with the compressed paper, and in many cages, they were actually getting all the way to the point that they could create a completely domed nest for themselves. And so, this kind of triggered our sort of last analysis I want to share with you. If mice are able to construct better nests, not only is that improving sort of their control over their environment, but what other tangible benefits is it bringing? And is there a breeding improvement that having a better nest or a stronger nest, or maybe potentially even a warmer nest, can bring to pup survival? And so in panel A here on the left, we're showing the results of tracking the 6-month breeding performance index for breeders that were either housed on corncob bedding or compressed paper bedding. And so a breeding performance index is looking at the number of pups produced per female mouse per week over the 6-month time that we analyzed them. And then on panel B, we're looking at those same animals, but looking at the number of pups per litter stratified by how many litters they've had, so for their first 6 litters of their life. And so excitingly, what we saw, and this was from wild type as well as a diverse set of genetically modified mice with 10 different genotypes, the breeding performance index was actually significantly increased in our compressed paper bedding, which we directly attribute to the improvement in the nesting. And also what we see in the number of pups produced over the course of their first 6 litters is that in the first litters that the mothers were having, we see an extreme improvement in it. That sort of this change in the improvement diminishes as the mothers become more experienced and have additional litters. But really, it's in these first time and second time mothers where the quality of the nest can kind of be conferred to allow them to really increase their pup survival rate, which we were very excited to see. And so, so just to kind of summarize here as we wrap up, I want to just kind of remind you of the objective benefits that we saw with compressed paper. So it reduced the spot change frequency in individually ventilated mouse cages when it's compared directly to corncob. Compressed paper or Puracell reduced the intracage ammonia levels in IVC cages compared to corncob, but did not do it in static caging. Puracell or compressed paper bedding increased the level of bedding incorporation into mouse nests, and it also increased the breeding performance index for breeding mice. The other things that kind of came up throughout the course of this study that we weren't as readily able to objectively show, but I think are still very valid refinements for this bedding, is the pure white color definitely does allow for easier health checks. If we're looking for blood or diarrhea or those signs, very easy to see on white as opposed to the sort of brown corncob. We did feel that there's reduced eye irritation. There's very little to no dust associated with compressed paper, which was nice to see. You know, beyond just the nest, it does increase their species specific behaviors. They dig in it, they burrow in it, they play with it. The soft texture, we readily use this for our post-operative animals here. Also for our colonies of aging mice that may be experiencing arthritis or other debilitations. So it's a nice soft bedding for them. And then another functional benefit is that I'm sure many of you have had instances where mice have wedged a piece of corncob bedding into a water or a lixit and induced a flood. The shape of the compressed bedding almost prevents that from being possible, which is a nice perk. And so the last thing is, you know, refinements are awesome for welfare purposes, for logistics, and really the topper would be for financial perspectives. To really realize the financial benefit of a bedding change would be to really push for an extended cage change interval where you could actually change these cages less frequently if you can promote the environment of the mice and keep them in a level of ammonia and cleanliness that is optimal for them. At this point, our institution has not chosen to go that route, but data like this is sort of one of the first steps along that path. And so with that, I would like to thank all of the people that helped our group collect all this data and do the analysis, especially Dr. Zach Freeman, a good friend of mine who worked with me very closely on this study, and all the other people that helped with the massive data collection. And so with that, I'd like to take any questions.
You do have some questions, Brooke. Were the static cages with a micro isolator top or open?
They did have a micro isolator top, yeah.
Okay. If the paper bedding keeps the liquid at the top of the bedding, are we then exposing the animal's feet to a wet environment? And does the air in the IVC cages across the liquid create a colder environment, necessitating more enrichment or changes in physiological parameters?
That's an interesting perspective. From what I observed, I would say no. So that bedding is dried very quickly. So the moisture is held right at the surface, and in IVCs, the air exchange rate is somewhere close to 60 potentially. We did not see overtly wet bedding. Absolutely not.
Okay, the next question, was there a standardized way the technicians assessed cage wetness that would trigger a spot change, such as looking from the bottom or top of the cage?
Yep, that's exactly how we did it. So if when they did their health checks of the animals, they noticed any reason to suspect that it might need a spot change, we would then look under the cage, and if you just kind of shift the cage around, you can see how much of that is wet or stuck to the cage, and it wasn't, if it was greater than 25%, we would just spot change.
For the nest building, was it just comparing the corn cob and the crinkle paper, or like in the picture shown, additional crinkle paper or nestlets were also given in those studies?
Yeah, so standard, all of our mouse cages will receive an Enviro pack with that crinkle brown cut paper. And then this was in addition to that. Absolutely.
Are you transferring the nest during cage change?
We try to as much as possible. If the nest is dirty in any way, we will take a portion of it just to try to keep some olfactory cues and territorial markings in place. But every new cage will have a new Enviro pack for providing nesting. So it's not a standard, but we try to as much as possible.
Okay. Is there any data concerning the effect of different bedding material on the diversity of gut microbiota?
Absolutely. And I think as most institutions see microbiome research start to take off, it's a bigger and bigger aspect that people are considering in their variables. And that was honestly one of the reasons we were interested in looking at this, because Puracell was created to be for toxicologic research, where you're trying to hyper standardize everything that you're looking at. And the corn cob can represent so much variability across the year and where you are in the country or world. Yeah, so we were not able to really dive into that, but it's presumed that there would be at least some benefit to reducing microbiome variability with this product.
Okay. What is the cost difference per bag of corn cob bedding versus the Puracell? They're looking at what the cost factor was in implementing.
Yeah, that's a great question. So unfortunately, compressed paper is significantly more expensive. The absolute numbers are going to depend on your volume consumption, but that was really where we kind of came into a pinch of financial benefits of this changeover, where on the per bag basis it's more expensive, but you are potentially wasting less product, you're saving labor hours. There are other avenues to sort of make up that change, but that's where really it came down to, if this was a financial decision, you'd almost probably have to extend your cage change rate to really find a financial benefit. But I would encourage anyone to kind of dive into their particulars of their facilities. At a massive facility such as ours, we go through a lot of product, and so we would have had to make it up in finding other usages for our technicians in that reduced labor from all the less spot changing. But we reasoned that the welfare benefits were such and great enough that our facility is now at probably a 70-30, 70% being compressed paper, but we still have many researchers that were a little resistant to change, so understandable.
Do you have any comments on the environmental impacts of corn cob versus compressed paper bedding?
The environmental impacts. They're both natural products. They're both minimally manufactured, and so I think they're biodegradable. I mean, I'm not an expert in disposal and environmental aspects, but from my perception, I wouldn't see any difference. I mean, they're both natural products.
And then we have one question that I think you probably would be better to answer, type up an answer, because it has to do with testing and procedures in in a place like Pakistan where they don't have the same level of authentication of products. So if you could answer that one directly to
absolutely.
the requester, that would be appreciated. Okay, thank you very much. Very engaging and encouraging for people to know that there's this product out there that seems to be really making a difference for the animals' environment, and their bedding option too is good in terms of absorption.
Absolutely.
All right. Okay, so for everyone, we are taking a break now till 10:15. So if you want to join us back at 10:15, we have 2 more presentations for the morning session. Thank you.